All right, well, we are already ready for lesson 10.2. And if you did 10.1 and the intro to 10 yesterday, so far, I had a hard time getting Mrs. Wheeler's lesson to load. But if I can get that in there, she just has it in a different format. I will put it in, and I would recommend watching that one too, because she's going to just put a little different twist on explaining some things that she'd already started talking to you about. So I am going to go ahead and continue doing my own lessons just in case I can't get something for her or from her to load, but I do want to try and get information from her in to you. So we are in the big book, page 385, and our learning goal is to I can classify triangles by the size of their angles. And yesterday we talked about a right angle, an obtuse angle, and an acute angle. And very quickly before we begin, you know how I am, I like to kind of review some things. A right angle has to be a perfect square. So something has to be able to, a perfect square, which what I drew wasn't perfect, has to be able to fit in that angle for it to be a right angle. You may see most often somebody draw a little square in there to show that it is a right angle because it forms the sides, two sides of a perfect square. So that would be a right angle. This would be a right triangle. If you have one corner where you can slide a perfect piece of paper in there, it's going to be called a right triangle because of the right angle. If the triangle has one angle that is greater than a right triangle, which would be here, if it has a side that has greater than a right, obviously it's going to have two acute angles, but it has one side that is an obtuse angle greater than the right angle, like this one. This is going to be obtuse. And then if it has an angle that is acute, it will end up having three acute angles. So this is going to be, when we refer to acute triangles, it has to have acute angles less than what this paper would fit in. And I know this one seems, I gotta make it a little bit, this one seemed like maybe it would have fit in a 90, but acute has to be less, three angles less than right angles. So just a review there real quickly. Okay, so a triangle is a polygon. Yesterday we talked about the word polygon. A polygon is a closed figure with straight sides. So this would be a polygon for sure. It has straight sides and it's closed. So if there were little cows in here or doggies, they couldn't get out anywhere because there's nowhere to get out. That's what means it's closed. So this angle right here, this triangle rather, is a polygon with three sides and three angles. And you can name it by its vertices and angles. Now, there are several different names for this triangle. This triangle could be A, B, C, C, A, C, B, A, C, B, A, C, A, B. So 6 different ways to refer to that triangle, but it goes around one way or the other, or starts in a different point and names each of the ways it could go. So an angle of a triangle can be right, can be acute, or can be obtuse. So we're going to identify right, acute, and obtuse angles in triangles. The book says that you need colored pencils. You know me, I'm just gonna make work here. We are just going to write a letter on in the inside here to tell whether or not they are right, obtuse, acute. So let's use an R for right. An O makes sense to me for obtuse. And an A for acute. Craig, what do you think this one is?
Acute.
Why?
Because it's less than 90 degrees.
Okay, so write an A in the middle there. Okay, what about the next one to the left here? Obtuse, because this is greater than, I can't slip this piece of paper in there perfectly. That angle is wider. There are two acute ones, but if it's got one obtuse, it's obtuse. Craig, thoughts? Right. Okay, you see the right angle there? Oh, found the right angle there too. Are you finding that little blue box helpful?
Yeah.
The right angle there. It's a right angle there. What about that guy? Obtuse, one greater. And acute and obtuse. So he is correct. Okay, now you're looking off here to the side at these three angles. And we can name them whatever we choose. But tell us the name of a triangle with one right angle, Craig. First of all, point to it. Yeah, but down here where it's asking for it.
Oh.
One of these three. So what would you maybe name that one?
A right angle? What?
Yeah, but it's got some letters there. So you're going to draw a little
PQR?
triangle and then you're going to name it what?
PQR.
Okay, PQR is fine. Triangle. P, Q, R. And I actually think that they just write their little triangle next to it, not above it like we did with the line. So would you take away that triangle that you wrote above, write it next to it at the beginning? P, Q, R, triangle.
That's an A.
Okay, I'm going to zoom in on that little triangle P, Q, R in sort of some smeary little scribbles there. That's okay. All right, so name the triangle with one obtuse angle. Which one has an obtuse angle? Okay. You can do it this time. I know you can. Triangle. X, Y, Z. Very good. And name the triangle with the three acute angles. Triangle, good. You're a quick learner. A, B, C. Very good. All right, we're going to turn the page. They give us another little diagram. Acute angles, these are smaller than 90 degrees. Doesn't matter what they measure at. We're not talking about that yet. They are smaller than a right angle. Obtuse, greater than a right angle, and right angle. So these are acute triangles, obtuse triangle, right triangle. And they don't always look the same. It always depends on what angles are there. So this one said to use a Venn diagram to classify, which it looks like with Mrs. Wheeler you've already done. So instead, we're going to do exactly like we did on the page before, where in the middle we just wrote an A for acute, an O for obtuse, and an R for right. So Craig, I'm just going to go ahead and videotape you doing this or record. So I like how you found the R. This has a little box here that shows that right angle. Not always do they, so sometimes you have to get the piece of paper out. You gave this one an A for acute because the angles are smaller than the right. Right here. There's an obtuse angle here. That one you might want to check if you're not 100% sure. So you'd put that on the line, and then you'd be like, oh, yep, this line goes out greater than a right angle. Obtuse, obtuse, acute. Okay, and then you did have them written down here below, acute triangles, and then you named them R, S, T. He has that there. But you should already have done that. If you didn't, you're welcome to put those down there, assuming that you didn't miss Mrs. Wheeler's class that day. You probably already have that done. The show and share here says name the triangle and then tell whether the angle is acute, right, or obtuse. And so Craig says that the name of the triangle is HFG. Now, you might have something different because that triangle could be FGH, HGF, right? You could come up with several different names for it. And then it asks you for the angles within the triangle. So it's asking you about angle F. So you're gonna come over and you're gonna find angle F. Angle F is less than a right angle. So it is acute. And he put acute. You're gonna find angle G. Angle G forms that perfect square. Angle G is a right angle. And H, you're gonna find angle H. Angle H, you might have to tip it around, turn the book over, whatever to see that angle, but H is also acute. So he has labeled acute. Okay, this is asking you to classify the triangles, writing acute, right, or obtuse. Mrs. Wheeler must have already had you do this. Obtuse, greater than a right angle. Obtuse, greater than a right angle. Acute, none of these angles are greater than a right angle. And you can always take a little piece of paper and you can see if that fits inside or if it is wider than the edge of a paper forming a perfect square. That's going to help you. So you're going to go ahead and do the on your own on 387. I realize you maybe have already started it. Craig already has it done. So if you're thinking that he might be right, you can certainly check his answers to see, because he does have those done already from when we were back in school. I'm going to turn the page and just show you that you can also do the problem solving. This is probably not a bad idea to try and figure out what they're talking about there. And it gives you just a little bit more practice since you've already done some of the work on this page. And then you can come to the skinny book and you can find page P191, and there is some more practice there, front and back. And I know that Mrs. Wheeler did say she also has some IXL practice for you. I am going to have you stop the video now and go ahead and work through the pages that we just talked about in the big book, 387, 388, and the skinny book where we were talking about 10.2, which I just closed, on P191 and P192. And then I'll have you stop the video and work on it. And then I am going to flash over the answers here so that it's easier on moms and dads. So stop, don't be looking at the answers, but I'm going to show them next. So click on it when you get this done. Here is the answers for the on your own on 387. Here's quite a bit of writing. I'm sure you'll work through these. You might not have that much writing, but there's the answers for those. Here is the skills practice on this in the skinny book answers. And here is the back side where the multiple choice ones are. Remember, for those spiral reviews, you can always go back to the actual lessons some of that stuff is coming out of. It usually says, it's really written very tiny in my book, so my old eyes don't work really well. Regardless, there may be some additional information coming from Mrs. Wheeler, so also be looking for that. Happy triangles.